Hello, I'm Graham Horton. Welcome to today's video. It's another in my quick build series. Now this is a series which is introducing electronics to photographers to help you build some projects which may help you with your work. Now today we're going to look at building a lithium-ion power supply for powering your camera, such as I've got here, which is powering this Canon EOS M5 on the desk. It's a 2 series lithium-ion battery pack and the associated battery protection circuit. Very simple to build, very quick to build, and will give you plenty of enjoyment if you're going to externally power your cameras for an extended period of time. Let's have a look on the desktop here at the components we'll need. I've got two 18650 lithium-ion batteries rated at something like 2600 milliamp hours, which gives me double the runtime of the standard batteries that you have in your camera, such as the BLC12 for the Panasonic Lumix FZ series. I've got a battery holder, which is an 18650 battery holder. Now these are generic type of holders, and they can be clipped together to give you a parallel circuit, or you can get them in threes to give you 12 volts, or you can parallel them to give you 12 volts and an extended capacity. So they're multifunctional devices, and for that reason, if we look on the desk here, I have already assembled this particular one and I've marked up which is going to be the positive and negative for the batteries. These two are going to be in series, so I've marked where the positive of the battery will be in the negative, and like the other one will be the other way around to give me a series circuit. So this one with the positive and that's the negative. On the other side, I've just marked where the connections to the battery protection circuit will go, so that will be the battery plus, this will be the battery minus, and at the bottom I've just paralleled the two contacts together to give me the middle point of the battery, and here's a bit of wire so I can connect it. So the actual heart of this is the battery protection circuit based on the HY2120 chip, which is this very small chip here on the board. These are two high power MOSFETs which will enable the charge and discharge from the battery. A much smaller device is this one with the same chip, the HY2120, with two smaller MOSFETs. These are capable of controlling currents up to about 2 amps, where these will contain current up to about 8 amps. So I'm going to be using the bigger one today to allow more current to be taken from these high capacity cells. I've got a cable here which is a preformed cable. It's already got the 5.5 by 2.1 millimeter connector already in there. You could use the ones you wire yourself, but I got these on Amazon with the cable just so I can just connect them without any other additional wiring. Also need just a bit of jumper wire to connect the battery. So let's just have a look at that HY2120 chip to see how it works before we start assembling this project. So this is the actual schematic for the HY2120 chip, which is the one that we'll be using on this particular module. Essentially, the circuit allows us to put the two lithium-ion cells in series, so the 4.2 volts will be added to the 4.2 volts to give me an 8.4 output on the device. Around the chip are support devices. The R1, R2, C1 and C2 are just decoupling circuits for the supply if there's any ripple on there when we're charging. Not strictly necessary, but they're provided to add that decoupling for the supply rail. The main feature is R3, and R3 is chosen by the manufacturer to limit the current, and a typical value would be 2K, and that's what we'll find on our circuit board. We've got two MOSFETs here, two N-channel MOSFETs, which are used to either open the negative line of the battery in an overcharge situation or open M1 in an over discharge situation. So either one of those situations will cause a opening of that line, which will then disconnect the main supply. During charging, if we get an overcharge situation, the sense voltage on R3, it will open M2 and disconnect the negative side. And again, if the chip finds C1 or C2 have fallen below the 3.2 volts, it will open M1 and again disconnect the negative line. So quite an important chip for battery protection, for overcharge and over discharge. So in a normal situation, if cell 1 and cell 2 are within the limit for discharge and over current, both OD and OC will be high, closing the link through there, so we got output or input for charging. So let's have a look at what we'll be assembling today. We've got the battery box, which I've just marked up with the plus and minus for the battery protection chip. The bottom half of the battery box I've shorted together with the extra tail for connecting to the battery minus. It allows me to, or when I put the batteries in, I know where the positive and minus is. So I've got them in series and did together, so we've got 8.4 volts output. This is the actual battery protection circuit, and I've just soldered on here some short lengths of wire so I can connect them there. Optionally, I'm going to install a voltmeter to the output, and with a small push button, I can press the push button and monitor the voltage on the output. So if I'm using this on my camera, then I can actually just press the button just to check the voltage to make sure we're not dropping below something like 6.2 volts, which would then shut down the camera. So I've got an idea of how much capacity is remaining by just looking at the voltage. Just need to solder on the input or output cable, which is going to be this 5.5 by 2.1 connector, and that will go to the battery management board. So basic tools, you just need some solder, a soldering iron, a pair of cutters and some small pliers if we need to bend the cables. So let me set up to solder this together, and I'll join you in a moment. To facilitate the mounting of the battery protection board, I've just applied some double-sided adhesive tape to the back of the module so I can stick it onto the battery box. So we just remove that, and I'm going to stick it onto the back of the unit so I can solder those two wires onto the terminals. So that will be positioned there. Then I just need to connect the common wire to battery minus, the negative to negative and positive to positive. These are marked B plus and B minus, so they're the ones that go to the battery, and B middle is the common in point. So I'm just going to connect that common in point over to the B minus, sorry, BM. So I just trim that to the length. Like that, and we just need to apply some solder to that. Like so, and now we'll just connect the positive and the negative leads to the terminals on the battery box. Again, just solder those in place. So that is the B plus and B minus connected to the plus and minus of the battery connector, and the common point across the bottom connected to B minus. We just need to connect our input cable, or it's the input output cable, and again this one will go to the terminals that are marked P plus and P minus. So P minus will be the negative lead, P plus will be the positive lead. So I'm just going to solder those onto the board. Let's clean the iron, a little bit of tinning. So P minus, we'll solder that into there. and P plus onto here. So I'm going to apply just a little bit of hot glue to mount that to that position to keep it in position. The rest of it is fine. So here we have the completed module with the battery box, the battery protection circuitry and the input-output lead. So what I'm going to do now is install the two 18650 lithium-ion cells into the holder. I'm going to show you how we can start charging and using this device. So let me just switch over to the overhead, and you can see I've got the battery terminals marked so that this will be the positive of the cell and the bottom will be the minus. These cells already have battery protection circuits, but it's still okay to use them in this sort of situation. So I'm going to install the first one and we'll install the second one. Of course, this is going to be the positive and this is going to be the negative. So we'll connect that into the circuit. Now, normally when you first start to use these circuits, they are inactive and you need to put a charger on there to start the circuit going. But what I'm going to do is first of all test that, and I've got here a inline voltmeter that I've made. So it's just a female socket to female socket bonded between the two to give me a high current. Then across there, one of those voltmeters so I can actually measure the current. So I'm going to plug in the device. Remember, our battery power supply has got a female socket to keep with convention that having a power supply will have a socket rather than a plug for safety's sake. So when I plug this in here, notice there is no output from the device, as this needs to be connected to a charging circuit to switch over the 2120 chip to enable both Q1 and Q2 to be energized to allow output. So that brings us nicely on to how to charge this circuit. Now there are three ways to charge it. I'm going to show you two today, but then introduce a third one, and we can use that in a later video to talk about step up and step down power supplies. Now the easiest way is to use a commercial 8.4 volt charger. Now this is one I have for a LED headlight. So it's 8.4. I'm just going to plug that into one of my sockets on the desk here to give me power. And if I just plug in my voltmeter, we can see that it's currently about 8.47 volts. So you can see that on that display, 8.47 volts, 8.46 volts. Now, I'm going to connect this to the charger, and that will initialize the U1 device on there. So I'm just going to quickly connect that. Now that would have enabled the circuitry, and if I now plug in the external voltmeter, we should see that this is now turned on, allowing us to use the full potential of the battery. So let me just plug that in there, and you can see this battery is now giving an output of 8.32 volts. So it's almost 100% charged. Now it's worth a mention here as well that when you install the two 18650 batteries, to try and get two which are almost the same potential, so fully charge them before putting them into this unit, then you've not got a situation where one is almost full and one is almost depleted. So it's better to have them fully charged or the same potential when you're going to use them. So now we can actually use this on a device, and what I'll do is to unplug the battery pack that's on this particular camera, which is on HDMI 2. So this is a image from this camera. So I'm going to switch over. We'll turn off the camera first of all. I'll unplug the lithium ion battery pack, and now I'll plug it into this device. And we can see the voltage on the device is still showing 8.32. I'll turn the camera on. The voltage drop on the cable is getting us 8.21, but the camera is still live, and if I show you the image from it, you can see we were using this power supply to control the camera. So we're going to get about 2 times the runtime of the normal battery in the camera, so it's a great addition if you're using it. Some of these commercial modules come with a nice little carry case, but you could probably find a pouch to put this device in. Now, I did mention that I was going to add an additional push button, which I've done to another cell that I made up earlier. So again, it's just the voltmeter, which is pre-wired, and a push button across the battery plus and the battery minus. So if I want to measure the battery voltage, all I have to do is press that button and I can see the battery voltage there. I turn it around again for the right way around, is 8.35. Normally you let these discharge to about 6.2 volts, which is 3.6 volts per cell, which is normally the cutoff voltage for these lithium ion cells. So if we're using this here in the studio and is using that power, I would normally connect my series voltmeter so I can actually measure the voltage. So currently it's what, 8.16 volts. So I know there's plenty of life left in that battery, so I can actually carry on filming. Now I did produce, and it's somewhere, here it is, another of these voltmeters in a small box. So let me plug that into this other cell. Again, this one needs to be switched on, so let me plug the 8.4 in there. So that would have then energized the U1 chip, and you can now see in my inline voltmeter, which I normally use when I'm using an external power supply to keep an eye on it, showing me about 8.35 volts. So we know that we got plenty of capacity left in that cell. Now the other method of charging is to use your existing battery charger. Bit unconventional, but you know I'm an unconventional type of guy. So here we have a standard battery charger for the Panasonic Lumix BLC12 battery, which is used in the cameras from the FZ100 all the way up to the FZ2500. So it's a standard charger. To charge it, obviously you just place that into the battery charger, and you can see we've got the red light there showing that we're charging the battery. But what I want to use is the dummy battery pack that you've probably seen me use in several other videos or on my photographic blog. This goes inside the camera, it's got an external lead, and you can plug it into your power supply. It's much the same as we're using here with the studio camera. So this then will go into the charger like so, and the normal lead that would so this will go into the charger. The normal lead that you would connect to your external power supply will be the input now for the battery pack. So we'll put that into the charger, and here we've got the battery pack. So I'll now connect the camera battery to the unit we've just made. Plug that in there, make sure this is seated, and it's sufficiently charged in this situation. So we've still got a green light on the battery charger, which means that this unit is full. Let me try to find one which is a little bit more depleted. So maybe the one we've been using on the studio camera today will be depleted. Let me plug that in, and yes, we've got the red light on there, so it means that this is charging the similar sort of pack in here that you've got, so you can use this. Now in the next video we're looking at step up and step down power supplies and how we can use them with something like these power tool batteries to power your camera. So here's a step down unit, slips onto one of these power tool batteries. Again, you can see the output voltage is 8.0 volts, so enough to power the camera. And we'll be looking at step up and step down power supply units, so you can use them for extended periods of time if you're going to be out shooting for a longer periods of time. So that basically is these lithium ion battery packs. Hope you found that useful. I'll put full details in my photographic blog, the Electronics for Photographers page, so you can see how these are made up and the parts you'll need. So until the next video, thanks very much for watching, and of course if you are a new viewer and you're liking the series already, why not hit that subscribe button and the bell notification icon to be advised when I upload the next video. If you've not already seen my photographic blog, I will put a link in the video description below so you can check out some of the other articles on all the Panasonic Lumix bridge cameras and some of the Canon mirrorless EOS M range. So until then, thanks very much for watching. Please do take care, and I hope to see you all very, very soon. Goodbye for now.